Hi everyone, good evening to all. Today we are going to discuss about of Fan's law for variable speed of centrifugal compressor, and this is also called affinity law. And I'm sure this video is going to be very interesting. So please do keep watching until then and subscribe my channel. Thank you. So let's begin the discussion on affinity law of variable speed. Fan's law has a relationship with inlet actual flow, head, and power for variation of speed of impeller or the wheel, and this can be used to see the change in inlet actual flow, head, and power due to change in the speed. Okay, so inlet actual flow Q is proportional to speed of diameter, so Q is proportional to N. So we can also write Q2 by Q1 is equal to N2 by N1. Now derivation for this Q, how this Q is proportional to N, that is for derivation. So flow coefficient is equal to inlet actual flow Q upon pi by 4 d square into U2, and outer tip speed U2 is equal to pi d. Please read again. It is d square. So flow coefficient is equal to Q upon pi by 4 d square into U2, and outer tip velocity U2 is equal to pi d n upon 60, and flow coefficient is equal to, then again write Q upon pi by 4 d square into pi d n 60. So only variable is a speed, so this can be arranged at inlet flow coefficient Q is equal to K into N, because all are constant. So Q is proportional to N. So inlet actual flow Q is proportional to speed, that is N. Now head can be isentropic head or polytropic head. Head is proportional to square of the speed or diameter, that H is proportional to N square, or S2 by H1 is equal to N2 by N1 to the power 2. Now again derivation for H, head coefficient H upon half into U2 square, but U2 is equal to pi dn by 60. So head coefficient H upon half into pi dn by 60 to the power 2. As the only variable is speed, so this can be arranged. H is proportional to K, H is equal to K into N square, and K is constant taking all factors, so H is proportional to N square. So head H is proportional to square of the speed N. Power. Power is a proportional to cubic power or cubic of speed of impeller, that is P is proportional to N cube. So another way, P2 by P1 is equal to N2 by N1 to the power 3. So now derivation for power. Power is equal to inlet density into inlet flow, inlet actual flow into isentropic head upon isentropic efficiency. Assuming inlet density efficiency are constant, so inlet actual flow is proportional to N. We have seen this, and head isentropic head is proportional to square of the N. We have also seen this. Then only variable is a speed, so P is equal to K into N cube, where K is constant taking all the factors, so P is proportional to N cube. So power P is a proportional to cubic of speed N. Now let us understand with an example. A centrifugal compressor handles gas which has inlet flow rate of 10,000 meter cube per hour. Isentropic head rise 80 kilojoule per kg at design speed of 12,000 rpm. Calculate the inlet actual flow and isentropic head rise at a speed of 9,000 rpm. Solution: given Q1 is 10,000 meter cube, N1 is 12,000 rpm, N2 is 9,000 rpm, H1 is 80 kilojoule per kg. Find Q2 and H2 at a speed of N2. So Q2 by Q1 is equal to N2 by N1. So Q2 will be 7,500 meter cube per hour. Again H2 by H1 is equal to N2 by N1 to the power square. So H2 is 45 kilojoule per kg. So I hope you have enjoyed this. Thank you for watching.